Today we are going to welcome back to my 20th episode on the uh, collections and streams. And last episode, I did tell you that we will take an example where uh, we will use the traditional way of, processing collections for a particular, uh, task, and then we will do the same with uh, streams. So let's take a new example here where we're going to deal with transactions and say I have a class here again. So this is the class test say 2, 3, and then what we are going to do is that I'm going to write my public static void main here. So let's have a main method, min, and now in this one, what we're going to do is that we are going to have a transaction, and in this the transaction is of type list. That means I'm having a list of transactions, and the list is of type say transaction. Let's do this way. So list transactions, let's say it's a grocery transaction. Grocery transaction. Equals new array list, and that's of type transactions. Now in this one, in this transaction, I have to take this grocery type transaction and I need to sort this transactions. So how are you going to sort these transactions? Uh, this is new array list. And I don't know what is transaction here, right? I'm defining this as transactions. Let's worry about that later. No, not right now, but say we will have a type of transaction as an object. Maybe I'll create a class transaction, and then, after that, we will try to collect these transactions and sort it. So I'm going to have an advanced for loop for transactions. And then what I'm going to do is I'm going to add those transactions which are related to grocery inside the list. And then what I'm going to do is that, so let's have a transaction class since we need it. Let's call this as transaction. And then it is asking me to create a transaction class. Let's try to create a class transaction. Okay. Now, this one, let's not focus on details of this. Let's assume we have a class here, transaction class. And then in this, we have the members of the transaction class. We have four members. One is transaction ID, one is the amount, one is the transaction date, and this transaction is deposit or withdrawal. This is the simplest way of you can imagine what a transaction is. Now, having said that, let's go back here. So we made a transaction of type grocery, and then we are putting a once for loop for this one. It says transactions cannot be solved to a variable. So we are talking about a transaction class. I have, just declared a transaction class as an example. Now here we're going to see one feature of collection where we're going to sort the collection or a list by custom sorting, which I did not discuss in any of my collections episode, but we'll see the example here. So let me introduce first the concept here and then let's go to the examples. Uh, what exactly happens is that a collection can sort. Like, let's take a very simple example of what we can take as we had taken country list or Java and we have converted this to an uppercase, right? And I can just take another example here, array list. And what I can say is this is already sorted, but I will put XYZ first. Maybe, I will put another example here, my list start. In the end, I'll put as Sunil. Now, this is not sorted, right? I want to sort this. So I will simply say collections dot sort. And what I can do here is I can do this list, my list. And then I can give the system.out.println here. Let's see what happens. Let me run this example. So what I'm doing is I'm using collections.sort. Now, why I can use a collections.sort here is the answer is very simple. Now, why I can use collections.sort here? The simple answer is this, that uh, the list here is an interface, which is again derived from collection. So I can use collections.sort on list, on array or an array list. And that's what I'm doing here. I'm using this in the example here, basic array list2.java. Let me run this. I'm sorting this by the natural sort order. Let's see what happens. Okay, it is taken in the first as Ramesh, then as Anil, then as Sunil, and then as XYZ. Why did it take Ramesh first? And why did it take Anil afterwards? And then it has taken Sunil, and then it has taken XYZ. So what is the natural sorting order of this collection? So I added this list: Anil, Ramesh, Zahim, Sunil. Now Z comes in the last. Sunil comes before that, right? It should sort. So it has sorted this in the natural sorting order and then given me the result that Anil came first, then Ramesh, then after R yes comes, then it is yes, and then it's Zahim. So this is a natural sorting order of the list. But I do not want the natural sorting order. I want to sort it in my own way. So how do I do this? So that's where, the collection gives you methods to do custom sorting. We're going to talk about the custom sorting now and how we implement the custom sorting, the example we are going to discuss. So here I have taken transaction as an example purposely, to showcase how do we do custom sorting in collections. And then we compare this with the streams, and then you will come to know how easy it is, to do with streams compared to the custom comparator of collections. So we have an example here. We are taking a transaction. A transaction in a simple sense is just a class where uh, I'm going to take ID, amount, date, and transaction type. And when you construct the object in the transaction, it's to its constructor, it takes the string ID, the double amount, the date, transaction type, then it constructs a transaction object and gives it to you. So I'm constructing a transaction object here where I'm giving the ID and then amount and the date. This is a type of transaction. So I have three types of transactions which are grocery, and then the fourth one is tidy. Now, please pay attention at this point that I am going to first have an array of transactions where I put all these transactions. Then I'm going to use a list here. And then using an advanced for loop, I'm going to add only those transactions which are having grocery as a transaction type into, the transaction list. And after adding that, I want to sort this. Sort in what order? As per the amount. That means I need to get the highest amount first and then the lower amount. And how do I do that? So for that, you use the collections.sort, but you give arguments here. You give the collection, that is list, which you want to sort, and then you also pass your comparator object here. So I'm passing the comparator object here, and I'm overriding a method here that is override public and compare. I take the transaction objects here and then do a compare. When I do a compare, it gives me an integer value. If it is right, it gives me a positive value. If it is, you know, uh, that means if this amount is T2 amount is greater than T1 amount, it gives me positive. If T2 amount is lesser than T1 amount, it gives me a negative value. So based on that, it's going to sort, and as soon as you print it, you will get it sorted. So let's do one thing. Uh, we are going to first comment this, then run. So now you see that it's not sorted by the values. The size is 3, but it has taken all the grocery transactions. The advanced for loop, we did that. And now we want to do a custom sort. So what I'm going to do is I'm going to uncomment this. And then get what is the, you know, uh, sorting order. Sorting in descending order. Let's run this. Now you see that highest amount is come first, then 260, then 250. The same example, if I want to do using streams, observe it is so easy. So now what I'm going to do is I'm going to take this grocery transaction. Observe this, both these operations, advanced filtering, advanced for loop to catch only the grocery transactions, and the customized sorting, all this can be done in a one single operation. So all I got to do is grocery transaction. I'm going to make a stream of that, and then I'm going to get the T here, and T dot get transaction type, and then after I get a transaction type, I'm going to compare transaction. This is comparing, and here I need to get the amount. And then after getting the amount, I'm going to map it to the ID, and I'm going to collect the list. So we did a stream here, and then we got a transaction type. This is the intermediate operation. We collected all the groceries here instead of putting the advanced for loop, right? Then we are sorting in the descending order. We're going to do a sort, that's also intermediate operation. And then you're mapping this to a list that I should be able to, print the list. So just to see if this works, we're going to comment this to operations. And let's summarize what we did before we run this program. We declared a stream. We did a filter operation. And after we did a filter operation for transactions of groceries, right? Uh, we want only transactions of grocery here. Then we are going to sort as per the reverse amount descending. Then we'll map this to a list. And in the list, we will have the list of transactions. Let's see what output gives to us now. Size of list is 0. There is some issue. So let's troubleshoot this. So we did a stream. That means instead of putting it to new array list, I'm going to have this here. And let's comment this. And then now let's see what it says. Cannot convert list type to list transaction. So this has been taken as cross-stage transaction to list string. No, we will convert this to a type as transaction. Will not say equals to. So now what we did is we did this operation of uh, stream, right? So whatever is there in this list of transaction, we prepared this list of transactions. We had put this in an array, and that I converted to as a list using arrays.asList. Put the tran here. Then I made a stream of this. I filtered for transaction as grocery, and then I sorted using amount as reversed, and I put that in a list. So let's run this now. So it's so easy, right? We achieved this just by one stream statement, which did everything for us. Earlier, we were doing an advanced for loop, right? You can see this. And then we did a sort, custom comparator. Then we got the results. But here, by using Java streams, we got this result only in one shot. So earlier I had written a mappings operation. The mapping operation we did because we wanted a list of strings, which is not needed for me right now. We did only filtering and then sorting. Then I'm trying to use an iterator, which is also not needed in this case, but just for the sake of simplicity and the demonstration of the problem, I have used the iterator. Otherwise, there is no need of using iterator also. You can use a for each after this to display. So hope you appreciated the power of streams here. And also I had not introduced the custom comparator, which you also saw here. In case you like this video, let me know. But before I leave, I'm just telling you the concepts of string and comparator. And you can make this more powerful by not just by using a stream, but you could use this as a parallel stream. See, I'm using grocery transaction, right? Instead of using the stream, I can use a parallel stream. What exactly it means? So here, instead of stream, I would prefer this to give as dot parallel stream. That's the only difference which makes here. And then let's see this. It's going to work more quicker because you could have more than one stream here. See, you got it. This is it. We are going to discuss some more operations for streams. I've discussed so far filtering and sorting, and I took transaction basically as an example here because in transaction oriented systems you often need performance, and streams really helps you for that. So we'll be taking some more example. If you like this video, please hit the subscribe button. Thank you. Happy Java coding.